All right, we are gonna do. I'm doing this a little bit differently. I'm using. See this thing right here? You hadn't seen this before, had you? And I'm actually showing you the whole entire. I'm showing you the whole entire screen this time instead of just a little square kind of box, because of what I'm doing. So this is. It's continuing section 7, or what is it? Oh, that's a little thick. 13.7, right? That's a little thick. Let's take that down a notch, about right there. And we'll make it a different color. Alright, so it's section 13.7. And what we're going to do, we talked about this yesterday. Remember we did the unit circle, and then we put all the main points, 0, 30, 45, 60, 90, and everything around there. Remember that? Mm-hmm. And we put what the cosine was and what the sine was as an ordered pair. So what we're going to do here, and I said yesterday, we're going to clip that circle and we're going to stretch it out. And this is it. This is the circle stretched out. Do you see the angles? See, there's 30, 60. Well, there's not a 45 in here, but it would be in between. Okay, so I did have it in 15-degree increments, so you did see the 45, but then it was just way too crowded. So I just went in 30-degree increments, all right? So 30, 60, 90, 120, all the way to 360 and beyond. Why would I even go beyond 360? That's more than the circle. Because what do you do to the circle? You're doing what?
Well, it repeats that one rotation.
That's right. You're going around the circle, right? You can keep going around the circle as many times as you want, can't you? So that's what this thing indicates right here, is going around the circle. So let's get on the pointer tool and see. And I mean, you could go. Oopsie daisy. Let's do this. All right. So I mean, look, you can go way negative and you can go way positive and all that kind of stuff. But we're gonna stick pretty close to 360. All right. Oh, I forgot to hit Shift key when I do that. All right. So what we're going to do is we're going to try to figure out what the sine's going to look like on a straight line curve like this. All right, because there's sines all over the place on the circle, right? Every degree's got a sine, right, or a cosine, or a tangent. Would you agree? Mm-hmm. So, but we're going to do just the special ones. We're going to do whatever the sine is at 0 degrees, figure out what the sine is at 30, at 45, at 60, at 90, all the way around. We did that yesterday, all right, but we're going to actually plot it on this graph right here. Does that make sense? All right. So at 0 degrees, now let's just am I on the writing tool? No, not yet. I got to be on that. Okay, watch this. This is just, I mean, just to kind of think about what's going on. At 0 degrees, right there, what's the ordered pair? It's 1, 0. Okay, I'm not going to do every one. We did one yesterday. I'm just going to do the main ones. 0, 1. And at 180, it's -1, 0. At 270, it is 0, -1. All right. So what I'm going to do down here is I'm going to come to those main ones, and I'm going to fill in a few of the ones in between. I'm not going to do all of them up to 360. It would just be too time-consuming, and I think just doing from 0 to 90 will be enough just to see what's going on. You'll see what I'm talking about. And what we're doing the sine. Okay. So let's write it like this: y equals the sine of theta. That's what we're graphing right there. And this chapter, these are going to be the questions. They're going to say graph this equation, y equals sine theta. All right? And this is what you would do. All right? Start at 0. You don't have to start at 0. You can start anywhere around here, but I'm going to start at 0. Yeah, theta, yeah, good point. Theta, I made this axis called theta instead of x. It's the same thing, though. All right, you could call it x. I think what they do in books, if I remember right, if they use x, they're usually having these things in radians. All right. If they have it in terms of theta, then it would be degrees. I think that's kind of a general way that they usually do that. All right. But it could be x or theta. Doesn't matter. What's that? Say it again. Oh, in the book it says theta. Yeah. Well, I think it might depend. Did they say theta when it's in radians? What about when it does one in radians? Is it t? Is that what you said? Say it again. With radians, does it have an x or a theta? The t? It's got a t?
Yeah, for radians.
Is that a word problem?
Yeah.
Oh, because it's in time. But just a regular one, because not a word problem. Because, right, this could represent anything. This could represent time, things like that. Try to find one in the book that's graphed in radians and see if they put it in x. I think they might. They still put theta even in radians. That's fine. It's no big deal. It's not like there's one right way to do that. All right, we're wasting too much time on that. Let's do this. At 0 degrees, remember, we're graphing the sine. I just want to find the sine. So at 0 degrees, what is the sine at 0 degrees? 0. It's the second one, right? Cosine is the first one, sine is the second one, right? So look, over here on our little graph, at 0 degrees, what's the value at 0 degrees? It's 0. So I put a little dot right there, okay? Just plotting points, basically all I'm doing. Right, at 90 degrees, let's do the major points, and we'll do the ones in between, okay? The quadrantal points, I call them the major points, whatever. Okay, 90 degrees, what's the sine? It's 1. So at 90 degrees, what do? We pop up here, and I don't have like lines to draw, but I'll just kind of eyeball it.
This,
all right?
the y1 is the same thing as theta 90?
Theta 90?
The 1 on the y-axis equals 90 on the theta
well,
axis.
I'm not sure that you're saying it right. This axis right here is the theta, or the degree axis, okay? So when this would be on the x-axis, and then the sine, right, of the angle would be on the y-axis. Okay, see, look, theta is kind of acting like an x, isn't it? For instance, if I graph something like this, if I graph 3x plus 2, all right, this is along the x-axis, this is the y-axis. It's the same kind of deal, isn't it? This right here is going along the x-axis, and then you're figuring out, you do what you do to it, and then what do? You figure out where you go on your y, and that's what we're doing here. Yeah.
I think he was asking, is the distance from 0 the same as the distance from 0 to 90 degrees?
Yes.
No, not necessarily. No, they're completely different units. They're not the same units at all. This is degrees. This is just a number. All right, so it doesn't have to be. I mean, it might look like it here. Maybe they designed this program and my increments in here made it like that. It doesn't have to be like that. No. Okay. So there really is not a relationship between how far you go from 0 to 90. I mean, I could have spread this out and had like 90 way out here, and still one just been right here, and you could still get the same graph. All right. That's what you meant?
Yeah.
Okay. Sorry about that. I didn't understand. But let's keep going. Let's go to 90. We said it's 1. We already did that. Let's go to 180. What's the sine at 180?
0.
So look, at 180 degrees, where do I put my dot?
Right there.
Right at 0. All right. What's the next one? 270. What's the sine at 270?
-1.
So look, I find 270 here, and where do I go? I go down to -1. Do you think I'm on here? A little up, about right there?
Yeah.
Okay.
A little bit to the right.
All right, I'll make it big enough. It'll work, okay? Now, if we go all the way around to here, this is 0, but it's also, if we go around the circle one time, it's at 360. So at 360, what's the sine at 360? It's 0. Now, if all you did was graph those points, it looks like it would just be, boom, straight line here, straight line here, straight line here. But we got to do these in between points just to see what it's going to look like. So let's do some of those. I'm not going to graph all these out. You did this yesterday. If you have it in front of you, it's in the book. It's like on what, 850, I think, if I remember right. Is that right? Yeah. 850. If you see those, or you can just memorize them. Okay, that's what we should be at that point where you can memorize them. Okay. Now you may not know what the decimal approximation is because you know right now what the exact values are, but I'll tell you what the decimals are. So at 30 degrees, you remember what the sine of 30 degrees? It's 1/2. Now that's easy. I know what the decimal, it's not even approximation, isn't it? It's exactly. So at 30 degrees, it's 1/2. Now does it look like it forms a straight line all the way through here? Now that looks like it's a little humped over a little bit, doesn't it? What about 60 degrees? Let's do 45. 45 is in between here, isn't it? So let's do square root of 2 over 2. Punch that in your calculator. See what you get for square root of 2 over 2 as a decimal approximation, because I don't have exact values over here. And it's about what?
0.86.
0.71?
Oh.
Yeah, about 0.71. So I got to eyeball a little bit. This is 0.5. This is 1. So 5, 6, 7, 8, 9. I don't know, about right in here somewhere. Would that be a good estimation? Yeah. All right, what about 60 degrees? The sine at 60 degrees is the square root of 3 over 2. All right, so what's the square root of 3 over 2? Now, Ryan, it's 0.86, okay, 0.87, which is close to 1, isn't it? It's a little closer to 1. So it kind of looks like this. You see what it's doing? It's actually curving, isn't it? Nice smooth curve. Let's do some more in between. We'll go all the way to 180, and then we'll stop there. We won't do the rest. We'll go between 0 and 180. So let's do 120. What's the sine at 120? Now remember what 120 is. 120 is like this. Right, the reference angle is 30. So basically it's the same as saying what the sine of 30 is. Right? What's the sine of 30? It's 1/2. So the sine of 120 is, I'm sorry, what did I say 1/2 for? The sine is the long one, isn't it? Okay, so it's the square root of 3 over 2. And it's positive, right? So 120 is positive. Square root of 3 over 2, which is that 0.87 number. 150 would be the same as what? 30 degrees. Okay, so that would be a half. What about an in-betweener? In between here. That's 135, right? In between those two. So 135 is the square root of 2 over 2, which is about 0.7, the same place as that. Okay, you see how it's working? It kind of looks a little straight. In the other class, I kind of made it look a little bit better than that. Like this one right here probably is better drawn about right there. And it kind of looks like straight line, but it's really not. It's like a little hill, like a little mountain, a little hump, okay? So it goes like this. Now what do you think it does down the other way? It's the same thing, except now we're having negatives, right? Because this would be the third and the fourth quadrant. What's sign in the third quadrant? It's going to be negative. What's sign in the fourth quadrant? It's going to be negative. We got to move on to the next one. Thank you, Matt. Oh.